So this is example 8. Water in horizontal channel accelerates smoothly over a bump and then undergoes a hydraulic jump. If y1 is 1 meter and y3 is 40 centimeter, estimate the value of v1, v3, y4 and the bump height h here. So in this situation, we have this situation, and then the difference is we have a bump here. Okay, so and then again I would like to remind you that the energy is constant, so mean if we could compare energy for point 1, point 2 and point 3 because all of this energy is equal, but we cannot compare energy for point 3 and point 4 because we have a hydraulic jump here. However, for continuity equation, you could compare all the point because the continuity equation will be the constant, the same, because fluid is water, so it is incompressible fluid. So we go for this question. Okay, so we need the question give us the value 1 meter here. So and then we have a 40 centimeter at point 3, 4.4 meter here. Okay, let's say we do because point 1 and point 3 is already given. So we compare the energy for point 1 and point 3. So and then we substitute all the value, we could get equation number 1 here. So and then from the continuity equation, so we substitute the value, we could get another equation as shown here. So from equation 1 and 2, we could do the simultaneous process here, solution. So and then we could get the value of V3 is 3.740 meter per second. And the value of V1 is 1.496 meter per second. So and then we could calculate the height after the hydraulic jump. So we know this equation, and then I hope you could change the subscript here. So we have 4 and 3 because according to the diagram here, the 4 is point after the hydraulic jump, and point number 3 here is the point before the hydraulic jump. So the equation will become like this one. So and then we need to calculate the float number. So we calculate the float number at point 3, we get it is equal to 1.89, and then we could calculate the value of y4, which is 0.89 meters. Now we go for the bump height. So first we compare point 1 and point 2 because if we see the diagram here, so it is come from point 1 and going to point 2. So we compare for point 1 and point 2. So we have this one. So we substitute all the value, and then what we need to do is the difference is we need to calculate, we need to add the amount of H inside the energy equation. So I think you still remember we have two types of energy. One is specific energy and one is total energy. So in this situation, we found we could use the idea of total energy. So the energy of, we have a bump here, and then we have a water flow. So mean the energy for this flow is actually the potential energy because we have the depth of this one, and also because we leave the water at certain level. So this is the height of the bump. So means we need to get the total height of this one. So that's why in this equation we need to put an H in the equation. So and then so this is the assumption that we make because we use bump to create hydraulic jump. So we could say that flow at bump is equal to float number 1. So it also happened in previous tutorial, for example in tsunami. If we deal with the flow on the surface, for example, the flow on the ocean. So the Froude number is equal to 1. So and then if we take this assumption, so we could calculate the value of V2 from this equation. So we could get that the equation of V2 is equal to 9.81 Y2. So means now we have two equations here. So however, however, we still have an extra unknown parameter. Here we have y, we have v, and we have h. But in this equation, we have v and we have y. So means that because we have three unknown equations, we need to create another equation to get an h here. So what we could do is, so for example, we compare the energy between the point 3 and number 4 here. So and then so we could have this one, and then that compare 3 and 4 here. It's not the point in the diagram. It is compare equation number 3 and equation number 4. Okay, please do not misunderstood. This is not point 3 and 4. It is we comparing, or we substitute the value of equation number 3 and equation number 4 here. So we will get this one. As I said, now the terms of velocity disappear. So we only have the y and the h. So and then what we could do, we still have another equation, which is the continuity equation. So we compare the continuity from point 1 to point 2. So we substitute as this one, and then we could create equation number 6. So by using equation number 5 here and equation number 6, as you know, we have only two unknown parameter here. So we could get that the value of y2 is equal to 0.61 meter, and the velocity at point number 2 is 2.45 meter per second. So and then this is not the final answer, because the question asks to calculate the value of h. So and then we substitute again in equation number 5 here. So we could determine that the h is equal 0.1907 meter.